Hello, this is our first class, and today we are going to talk about functions. So, functions is already learned in the elementary mathematics, so we will not cover the specific examples and the definitions. We will only cover some questions and some information that is not fully discussed in high school. So, here are some questions. And question one. So our solution from question one is this. So question one says that for any real number x, this relationship stands. So we want to find the fx. So here we would let x equals x plus 1 and x minus 1. And keeping in mind that if x is a real number, then the x minus 1 must be a real number. So we can plug in the x minus 1, and we have minus 1 plus 1. That should be equals to minus 1 minus 1. So fx is x minus 2. And this is the first question and the second question. So the second question says that for any real number x and y, this relationship stands. And we want to find fx that is defined on a set of positive integers. So for this question, our solution would be this. So firstly, we want to prove the following relationship. So, and the x1 to xn must be real numbers. We want to prove the following relationship. So how do we do it? So imagine, like, you have the this expression, and you can divide it into this x plus 1 plus this whole thing. So it should be equals to and this thing should be equals to so it goes along, and our final conclusion would be the f of x1 or plus 2 xn should equals to this. So the statement is proved. And here we let x1 to xn equals x, and the x is a real number. So when we do this, we will find that because there are n variables here, so that will be nx, and it equals to also n functions here, so nfx, and x is a real number. Is a real number, and n is a positive integer. So here we let x equals 1, and we have, and because n is positive integers, this directly gives us the expression of fx. So the problem is solved. And the third question. So for the third question, it says that for any real number x, this relationship stands, and we want to find fx. So for this question, we let x equals x 1 over x, and we have and also this relationship. And this gives us a set of equations, and we can solve this to get the fx. And here are some concepts that are not fully discussed in elementary maths. So first of all is the period of functions. The definition is this. So there exists a real number t, and for any x that is in the domain of the function f, this relationship stands, then we can call that the t is the period of fx, and the fx is a periodic function. And also, if the t is the period of fx, we can say that there exists a t that is a real number, and for any x that is in the domain of f, this relationship stands. So I think you can do, and so a function can have many periods, and the smallest one is called the smallest period of the function. So for example, for this function, the period can be 4 pi, it can be 6 pi, it can be 2 pi, but the 2 pi is the smallest, so the smallest period is the 2 pi. So there's a quite misleading point about this. So not every function has a smallest period, so consider the following function. So this function is actually called the Dirichlet function, and it is defined clearly here. And I'll illustrate why it does not have a smallest period. So let us say that the x1 and x2 are two rational numbers, which, according to the definition, we can have this relationship. Oh, and here we suppose that the x2 is greater than the x1. So we can, because of this relationship, write it as this, where the h is greater than 0, and also a rational number. So here we have this. Right? And do not forget that this definition, we can apply it here, and we find that h is the period. But however, do not forget that we can also take the average of x1 and x2. Now, I'll denote that by x3. And because the x2 is greater than x1, so x3 must be greater than x1, and thus this relationship stands. And h1 is greater than the 0, and is rational numbers. So because that the x1 and x2 are both rational numbers, so the average of them is also a rational number. So here we have, according to the definition, fx3 equals fx1. fh1, should be fx3, f1 plus h1 should be fx1. So this relationship also stands. So according to the definition, h1 is also a period, and because that the x3 here is the average of x1 and x2, so here the h1 must be smaller than the h that we introduced before. And we can do this to x3 and x1, and we will get a h2 that is even smaller than h1. So this goes on forever. So as you can see, we cannot find a smallest number from these bunch of numbers, so it does not have a smallest period. That is a quite short illustration. And the next thing we will cover is the odd functions and even functions, which is, let me finish this. The odd functions and the even function. So the definition for odd function is this. For any x that is in the domain of f, this relationship stands. If the function matches this, then it is called an odd function. So for example, look at this. If we define a function that is like this, and we want to see if it is an odd function, we do this. And the x is in the domain of in the domain of f. So it matches this relationship, so it is an odd function. And even function, the definition for even function is this. So another example. This function is an even function because so as we can see, this relationship stands for any x in the domain of f. So in any x for any x in the domain of f, this relationship stands. The f minus x equals to fx. This stands. So according to the definition, it is an even function. And we can understand it from a geometric point of view. So the odd function, it basically tells you that the function is symmetric, symmetric to the origin. And for the even function, it tells you that the graph of the function is symmetric to the y-axis. So y-axis. So this is a geometric point of view to understand it, and these are the contents that we taught today. And have a good day.